Hello, welcome back to the channel. So let's continue our previous video and do one more example based on the conversion of a sigma notation into a definite integral. So we'll follow the same processes, we'll follow the same steps we discussed in the last video. So if you have not watched my previous video, I would highly suggest you to first watch my previous video in order to get the full context of what we would be dealing with in this video. So we'll start with solving this question. So now my first step is to identify delta x and find my xi with respect to my delta x. So now if I write a general representation of a sigma notation for a Riemann sum, by comparison I can see that my delta x by only comparison should be 2 by n in this case, and based on this delta x I have to find my xi. So a general expression for xi is a plus I delta x, and since I already have my 2 by n, so my xi should follow this pattern, a plus 2I by n, right? And I clearly see that I can find this pattern in this expression, which is minus 1 minus 2I by n. So if I compare both of these expressions, I'll take the minus sign out and this would become 1 plus 2I by n. And if I now compare these two expressions, I can clearly see that my a is equal to 1, and I'll adjust this negative sign afterwards. So now, based on all the calculations we did, my xi becomes xi equals 1 plus 2I by n. And I hope it makes sense why we took this as xi and not this term, because we wanted an expression which would look like a plus I delta x. And in this case, since I had a negative sign, it gave me an idea that I'll have to adjust my negative sign in order to get this expression, which is a plus I delta x. So that is why I took this negative sign out in order to simplify my expression, and I'll adjust this negative sign afterwards when I'll solve the whole question. And we'll do this later in the problem as well. So now I got my xi as 1 plus 2I by n. My delta x in this case is 2 by n. I have my a calculated as well, because by comparison of this expression to this expression, my a is 1. So I got my a as 1. Now I also know that my delta x is b minus a by n, and since my delta x in this case is 2 by n, my b minus a is 2, and since my a is 1, my b is 3. So now I've got my endpoints as well. So my left endpoint is 1, my right endpoint is 3, and now I have to convert every occurrence of my xi to x and every occurrence of 2 by n to delta x, which will be changed to dx by following the steps that we discussed in the last video. You would also notice that we used a different method to calculate the endpoints in the last video, but in this case we used comparison to calculate the endpoints. So in order to find the endpoints, you can choose whichever way suits you the best. So if by comparison you can find your endpoints easily, you can use this method, but if you are not able to calculate your endpoints clearly, you can always rely on this method, because this method will always give you the correct solution. So now let's confirm that in this case as well. So in order to calculate the endpoints, as we discussed in the last video, we need our xi, we need the starting value of I, which is 1, we need the ending value of I, which is n. So I'll write everything down. My xi is, in this case, 1 plus 2I by n, and I'll divide the page in two halves. So on the left hand side I have my starting value of I, which will give me a. On the right hand side I have my ending value of I, which is n, and this will indeed give me my b value. And now I have to substitute I equals 1 in this case and find I equals 1 in this case and find xi over here, and I have to substitute I equals n in this expression in order to find b. So let's do that. Let's follow the first step. So my first step is substituting those values. So I'll calculate xi in this case, which would be 1 plus 2 by n, because my I is 1 in this case. In this case, since my I is n, my xi would become 1 plus 2n by n, which is 1 plus 2, which is 3. And now in order to solve for a's and b's, I have to take the limit n goes to infinity of this expression, 1 plus 2 by n. This will give me my a. And on this side, if I have to calculate my value of b, I'll take limit n tends to infinity, 3, and this would give me my b. And I see in this case, since my n approaches to infinity, this term would approach to 0, so I get my a as 1. And in this case, since 3 is a constant, I get my b as 3 when I take limit n approaches to infinity. And you'll clearly notice that the results we got by using these calculations are exactly the same as the results we got using comparison. So now, since we have everything calculated, let's move on to the final solution. So I'll write the sigma notation again. My sigma notation is sigma, my limit n tending to infinity, sigma I goes from 1 to n, e to the power minus 1 minus 2i by n, 2 by n, and that's it. I'll write the expressions for my delta x as well. So my delta x was 2 by n. My xi in this case was 1 plus 2i by n. So now I know that I have to change every occurrence of 2 by n in my sigma notation to dx. I have to change every occurrence of 1 plus 2i by n to x, and I have to change this sigma notation to the integral sign. And we have our endpoints as well. And now, before moving forward, let's simplify this notation as well. So I'll write the notation again. And e to the power minus 1 minus 2i by n can be written as minus, taken out, 1 plus 2i by n multiplied by 2 by n. And now you can clearly notice why we did this and what was the meaning of adjusting this negative sign at the end. So after simplifying our expression to the expression that we want, I'll convert this into my definite integral now. So my definite integral becomes, since I have my endpoints 1 to 3, my definite integral goes from 1 to 3, e to the power negative of the whole expression 1 plus 2i by n would be changed to e to the power negative x, because my x is 1 plus 2i by n, and 2 by n would be changed to dx. And this is my final answer. So that's it for this video. I know adjusting the negative sign in this case was a tricky part. Feel free to comment down in this video if you have any doubts related to that thing or related to the question as well. And don't worry if this adjustment seems a bit hard for you, because we will do this question again in a different way and you can clearly see whichever way suits you the best. So let's wrap up this video now. Thank you so much for watching, and please follow the channel if you want to get notified about the next videos that I'll be uploading. Stay tuned. Bye bye.